Okay, so I think we can get started. So the last meeting's items. So David was here giving us a overview of all the WhatsApp stuff and the OCI artifacts. And so I think a couple of us actually left some comments on the document that is that's a work in progress there. So hopefully the comments are useful and correct. And Kyle gave us a demo of the tools that he's using for artifacts. So
I know I'm very, very interested in seeing some of the tools that are coming out of that Kyle demonstrated. I know he mentioned that some of them will be eventually open source once he got the T's and C's from his organization completed. So I am waiting, as they say, with bated breath.
Yeah, we're working on getting it out there as we speak. So
do you have a timeline? No rush. Once again, no rush. I'm just for planning purposes.
Oh, like 2 weeks.
Okay, great. Thanks.
Maybe sooner, but yeah.
Okay, sounds good. Okay, so this week's items. So Kyle, did you want to?
That first one, it's kind of a follow-on from last week, but basically focusing on the search aspect of things. So we have this telemetry server, and I can show you, just to maybe help with discussion, the types of queries that we do against our telemetry server, which is queries that we'd like to do against a registry.
Okay.
If that's useful. If not, no big deal. But
no, it's okay. Wait, no harm in presenting. We are here to learn too. So, yeah. Before we go there, right? So, James, did you want to add something from the WASM side?
No, not particularly. I think you had mentioned in the Slack channel that just there was maybe some follow-up questions, so I was just joining to see if I could help with that. But if you put them in the document, we're reviewing the document and everything. We're going to discuss it again next week. So appreciate your input, and if you have any further questions, let us know.
All right, sounds good. Okay. All right, Kyle, sorry to interrupt you there. I just want to make sure everybody had their agenda on. Okay, so continue, Kyle.
All right, so let me share my screen.
Okay, let me stop sharing.
No. We're trying to get in my office. All right. Hang on, I'm trying to find the right screen. All right, there it is. Okay, so this is just some test data in our telemetry server. The thing that's a little bit different about this than maybe what we would want to do is that this is dealing with multi-repositories, right? So these data bottles that I talked about last time. These are just data. You can think of them as images. If you're just any old artifact, it's a particular type of artifact. So we have, a particular rich way of displaying them, but you can kind of ignore that for the purposes of our discussion, if you want. So we can look at, like, these things have descriptions. They have various aspects to them. But we can look at, like, this is like the bottle TW. These are the parts. You can think of them as labels, as layers, sorry. But our layers have labels to them, and we can select different parts by selecting labels with the Kubernetes label selectors. But then this is like the graph of, this is the bottle you're looking at. This is where it came from. And these are the bottles. I don't know why that line's not there. I have to ask about that, but this is what descended from this bottle. In other words, this is an ancestor of this bottle, and this is a descendant of this bottle. And we can click on it, and now we're looking at the descendant, and we can see that this is the ancestor, and so on. But that's kind of like the big picture. But the point is I want to show real quick is these. So there's different types of queries we do. So this bottle query is basically, I want to search by, it's equivalent of image ID. So that the digest of the config in the manifest, I want to search by that. That happens to be a very useful query for us to be able to do. And when you find them, then you get manifests. Like the result of that query is a set of manifests and repos of which you can pull those manifests from. By label selector, so we have labels on all of our bottles, and we can use the kind of Kubernetes label selector grammar to select by labels, not equals in like the set semantics. Those are all supported. And then bottles have authors, so you can search by author if you'd like. Description, that's just searching this part of the text. The signature fingerprint, so bottles can have signatures, they can be signed. Think signed images, right? Signed artifacts, cosign or notation. We use notation in our case. So you can search by fingerprint, you can search by annotation that's on the signature. Like basically this is the idea of what can this bottle be used for, is the typical thing we think of. And then there's these more complicated relationships, but they're extremely important. So parent is just another digest thing, but the idea, so remember I talked about ancestor. So a bottle has its data lineage, right, is what I'm talking about. So this bottle came from this other bottle. What I mean by that, a concrete example is I have a data set, that's a bottle, and I trained a model on it. Well, that model bottle, not to rhyme on purpose, but that model bottle would have a parent or a source is what we call them. But really it's its ancestor, right? So the source of that model bottle would be the data set. And you can have many sources, of course. You might have 5, 10, 20 data sets that you're training off of and building up a model on. And then that model might want to be evaluated. And so you might have another bottle with a bunch of evaluation results in it. And that would have a source of the model. And so the bottles point up the tree, so to speak. They point to their ancestors. But with telemetry, we can point down. So this is like the refers API kind of idea, right? So we can look for children of a particular bottle. So give me the children of such and such. You can also, so bottles are immutable, right? By the kind of nature of OCI. We're not expecting people to delete them from a science perspective. You don't want to. You did an experiment on this thing. You kind of want to keep it until you run out of space on your storage appliance, or you accidentally lose it, I guess. So because you don't want to lose experimental data, generally speaking. So we have this concept of deprecation. So when you make a new bottle, by default, if you just go ahead and pull a bottle down, you modify it a little bit, like fix a typo or change it in any way and push it back up, that by default deprecates the prior bottle. You can deprecate any number of them. And so this is our way of kind of library management. To keep the catalog small, we want to make sure that what users are seeing are non-deprecated bottles. And so we do that by explicitly deprecating them, by pushing new bottles. That new bottle might not be anything different than the old one. It doesn't really consume any more data, but it has a little thing in there that says, oh, this digest, this digest, this digest. These bottle IDs, in other words, these image IDs are what we are deprecating. And we can search by part as well. This is like, think of it as by layer. Give me all the manifests or bottles that have this layer in them. Another thing that we surprisingly did not have a need for until recently is search by location. We have location information in here, like the OCI reference. Where is this bottle or image or artifact located? And there can be many places, right? Because we collected over many different places. But we actually didn't have that till very recently. It's not in the branch that I'm looking at right now, but so those are the types of things that we find interesting to search on in OCI. I don't know if that helps, but that's we have other things in here, like we have a leaderboard where we can
So
organize things and so on, but that's not important for what you guys are talking about. Go ahead.
yeah, correct. So what is the backend that is driving this?
So the back end is written in Go. It's using Postgres as its database. Or we use SQLite for local development generally, but yeah, that's all it is. We might switch to a graph database at some point in time, but I kind of want to wait till it's slow, and so I can do a good experiment of switching over and seeing an actual performance improvement instead of doing it prematurely.
The other option I would think is actually to do the backend in using an OCI registry. That's what I would think would also be useful.
Yeah, I don't know how I could.
Okay.
Maybe that's a good thought experiment to work through, but I don't see how. Like I do not know how to search by image ID in an OCI registry.
Yeah.
I'd love to. Like that would be great. And you know, like I guess there's a search query interface that Zot has.
Yes.
That would, I'm guessing, answer some or most. I'm curious what your thoughts are. How much of this is covered by that?
I would say most of it is covered, but there could be gaps. Yes. So okay. So now coming back to, so that's just an implementation, right? A storage implementation. So for you, I think the most important thing is the OCI image spec is what it looks like to me is the more interesting thing, because you have chosen your own backend. Is that accurate?
So if you remember from last week, this guy only stores manifests and configs, but no layer information, no
Okay.
blobs beyond that config. With one minor exception, like if I click on one of these things, maybe I'll find, yeah. So there are some artifacts that we have in here, that are part of a part. But generally speaking, we just store the signatures, the manifests, and the configs, and those configs look like, I can show them to you somehow. Oh, here we go. Right. So this is the config. So our config contains this information in it. The sources, the parts, any metrics that you might have on this thing, the labels for this particular bottle, the authors, and so on. And then I don't know if I have the ability to show you the manifest, but we store that in here as well. The data itself is stored in any number of registries. So like this particular one is stored in this this is fake data I have in here. So this is reg.example.com somewhere, right? It might be stored in 5 different places, and this would have 5 different entries here.
Got it. Okay. So I think so your system design is basically split it into 2 parts. One is a metadata server and a blob, a sort of a image/blob store servers, right? So the metadata server you're saying is the Postgres, where you're doing all these fancy queries. And once the queries are answered, they will direct you to the actual blob stores, which are the registries. Okay. Got it. Okay.
Yeah.
And I think I think it would be nice if you could eliminate the metadata server entirely. If you could put everything in the registry itself, all your queries, everything gets sourced there, because that will be one less thing to manage.
And one less thing to get out of sync and so on, right? because there's data that could be put in here that may not be available at that registry anymore, or because it could have been deleted, or the registry may not exist, or whatever. Yeah, the architectural problem I have with that approach, though, is that we like a hard requirement is we support multiple registries and discovering across multiple registries, right? So I'd still have to have some type of federated thing on top of it. If I go search, you know, this one, and so on, right? Like go hunt them all down. And a weird thing within the government is using like credentials. It's not like this telemetry server does not have the interesting thing from a design perspective, from a security perspective, which is a very good property, is that this telemetry server has zero access. It has no credentials to any registry. It has none. The registry doesn't even have to be reachable. And in a lot of cases, it wouldn't be. So the data is the sensitive part. The metadata is not, right? So the idea of this is separating the two so that it's kind of like, you know, you go to a library, you know, you look up your little index cards, right? Like I want to find something about something, right? You go find that thing. That doesn't mean the book is actually accessible to you.
So that's actually a similar model that I shared previously regarding what they're doing in the AI/ML space around the model registry, where all they're doing is just collecting basically metadata. They're not actually storing the data itself. You can query it to whatever you need, and it's just mainly a pointer saying, hey, if you want the data, it's over here.
Exactly. Yeah, so I just thought that that might be useful to help with understanding what types of queries are happen in the real world that are more interesting than just the simple cases. But they're not that complicated of queries. I think they're all, you can kind of think of them as there's only like 3 or 4 different general classes of queries there. I think that's it.
Got it. Okay. Thanks, Kyle. Actually, so there's some interesting requirements here. I will note them down in the notes. Okay, so I think I think we need to summarize what the gaps are for your use case and how OCI/CNCF can help in this, right? So I think the one of them is the query interface itself. Would that be accurate, Kyle?
Yes, yeah, definitely.
Okay. The separation of concerns and security between the metadata queries and the registries themselves. Well, the at least on the OCI spec point of view, you have the cross blob mounts and at least Zot also does things like remote sync and all of that stuff, right? So there is a little bit of a federation in there, but I'm not entirely sure if that aspect gets answered completely. So, okay.
Right. Yeah. Like one of the aspects that our telemetry server supports is you can from a particular insertion date, you can dump all the new records, right? Because it's an append only log. So we can just dump out the part that you're missing. You can take that on disk, take it over to some other telemetry server and upload all of that into that telemetry server. And then that telemetry server becomes aware of all the other stuff over here. And they may not be on the same network. That's kind of the idea behind some of that.
Okay. So, okay. Okay, thanks, Kev. Okay, so let's move on to the next item in the agenda, which is so I also began getting involved with the Kubeflow community because they reached out with regards to the OCI artifacts. And so, like I said, I mentioned the last meeting about how they are using, actually how they want to get to a model registry and their use cases. So one is there is one tight loop where they do a lot of experiments where there is less interest, but once the publishing happens, then there is more interest because then it can be co-located with all the container workloads. So they don't have to manage one more thing, right? So I began to put together a PR for this. So let me explain how this works, right? So Kubernetes does all of these things using CRs, right? The CRDs. So one of the things that they have is, at least in this particular model, is they have a way to model various things. So for example, there is a way to model inference. There is a way to model storage that the inference will refer to. And then there is a way to build a pipeline. There is a way to batch a bunch of things. So the Kubeflow is basically a complete framework where you can run an entire MLOps pipeline. And the other one is MLflow, which is coming, I think that is being donated by Databricks, I believe. And Kubeflow was originally started by Google, but I think now Red Hat folks I see more of the Red Hat community being active on this. So the model, at least for us, at least is an immediate impact. What we have is something like an inference service, right? So what they're looking for is you have an inference service, you have your models that are stored somewhere in the storage URI, and when the inference service starts, the container workloads start. Before they start, this particular model data is served of this storage, and you can of course give some image name to it on the storage. And then once the model data is stored somewhere locally, the inference the image that is running from the inference workload, that will consume this model data and serve off it. So that is the model, right? So the PR that was actually putting together is trying to add the OCI registry as a model, as a repository for all of this stuff. So it would look something like this. I'm still putting, it's still work in progress. I'm just working on it very slowly. Yeah, so yeah, so this is what their providers look like. So S3 was the example that I showed you right here, which is right there. But there are other protocols that they can use to pull the model data. And this was the one thing that I was proposing that we add to this. And of course, and then there's the implementation of it, which is still work in progress. So what at least from a high level, my idea was this will pull in all the model data and all the referrers to it in one place, and let the container workload interpret it and run with it, because they know what the artifact type is. Therefore, they know how to play with that, right? So we don't. We are only a repository in between. So anyway, I would appreciate a review once this is done. I'll post a review for this. So I would appreciate some eyeballs on this as well.
Did you put that into the agenda doc? I'm not in the doc
Yes,
right now.
yes.
Okay,
Yes,
perfect.
I did.
Yeah.
Yes, I did.
Thanks, Ron.
So if you want more context on this, you should probably take a look at the conversation happening here. Again, the same thing, same set of requirements that you have, Kyle. That there is this additional thing that we do not want to manage, but it has all these properties that we like, content based, so that we have repeatable, reproducible experiments/builds. We have the ability to serve that. We have the ability to package it. We have the ability to tag it. We have the ability to search it, and so on and so forth. So a lot of that has a massive overlap with what OCI DispSpec is doing and ImageSpec is doing, and of course data lineage and things like that, which using reference. So we have all the right mechanism in the OCI DispSpec. The policy is all based on all the use cases around. Right. So, and this is one of the use cases that is bubbling up, because this community, they said we don't want to implement and maintain a separate repository, registry, and things like that. That is something that we would like to avoid. So if there is something that we can contribute from the artifacts, from CNCF artifacts point of view and from OCI DispSpec point of view, then this is a good fit, at least in my opinion. But it was actually this was a very surprising use case for me that came out of that work. Okay, so that's all I had for the agenda. Okay, anything else that folks want to talk about? If not, then we can call an early end to this meeting.
I'll say 30 minutes back, but this is really exciting. Kyle, definitely appreciate you providing some additional basic input on what you're working on over there. Looking forward to obviously seeing some of the assets coming out to the open source. And thanks, Ram, for sharing some of your initial work on the model registry integration with Kubeflow.
So, so Kyle, to actually expedite your search query thing, this is one of the proposals to the OCI side. The OCI will move very slowly. They're very. It's a conservative group, right? So because it's all the registries that are out there and things like that. So, so while progress is happening there, we can actually take a look at making an extension proposal. Which is CNCF queries, right? So the message is that we will use OCI DispSpec as the backend, but here is an extension, query extension that we can add, and registries may choose to implement. Some registries will, some won't, but here is a query extension that we can add that satisfies some of the use cases that are coming out, like yours and probably Kubeflow and things like that. And once that is sorry, Andy.
I was going to say this kind of bubbles up to on just some of the new features that are out in OCI 1.1, which is the extensions ability. And I guess going back to Brandon, do you have it? I think you're the one that posted the blog for OCI 1.1. Is that right? A couple meetings ago.
What you're getting at?
There was a blog that was going out for the OCI. Was going. Did we ever do we ever post that, or is that still up for review? That blog?
Oh, the OCI 1.1 blog finally went live, I think.
Okay,
last week.
Good. That's good. I missed that, so I'm glad that it went live. I'm going to go ahead and promote it because there's a lot of good material in there. So cool. And that and obviously one of the contents in there was the extensions call out. So it's a good use case of it.
Yeah, and that's specifically the way we namespace the extensions. They're using the underscore character that isn't valid for a repository name typically. And so it's one of those things where you can turn that on without having to be a full 1.1 registry. It's an area where you can't put anything else anyway.
That's perfect.
So I added that link as well, the blog link as well, Andy, in the agenda.
Perfect. That's going to be a Monday morning thing for promoting out.
Perfect. Yes. It's a very good summary, no doubt. So
Agreed.
I like that it says March 13th in the URL there. That's just how long it takes to get these PRs merged.
perfect.
Well,
Yes.
well, as they say, Brandon, isn't it still like March 15th, 2020 in many ways? I'm just saying.
For some of us, it is.
Uh-huh.
Yeah. I'm glad it didn't say April 1st, but so okay. So let's that's all I had, folks. I think I can I'll update the agenda at the end of this meeting. If I can come with more links so that you can take a look at it. So the CNCF artifacts work also, there is a PR out there somewhere which I'll track it down. And I'll add it to this list. So maybe that is the path to take. We can say that at least the expectation is that we have all this registry stuff that is coming from OCI, which we can directly and immediately use. There is this additional extension thing that we would like to slap on top of it. And some registries may have already implemented. Zort has implemented as a Zort extension, but we'll have to port it as a CNCF extension, which is not very hard to do. It's just a mnemonic replace, search and replace. But again, it's an extension, so other folks may or may not want to use it, right? So I think that's a good compromise to have. But at least it is sort of codified in some form. Okay, I'll call an end to this meeting then. Thanks for joining and thanks for sharing your work.
Thanks to all the presenters. Cheers all.
Thanks.